So, hi everyone, it's Massimiliano from PMDS here, and welcome to another episode of
Ouais,
our
c'est bon. Ils
podcast.
ont le retour.
Today, we're going to talk about
Ouais.
the world of reinforcement learning. What is it? What are its
Parfait.
applications? How is a project structured? We're going to try to answer these questions and provide you with useful tips to start your own projects or just learn more about the topic. This podcast is very special since it marks the beginning of a collaboration with Automatants and Polimi from University of Paris Supélec. Our guests today are Raffael and Mathïs, two members of Automatants. As usual, don't hesitate to ask questions and raise your hand to talk. In case you have no raise hand button, you have to update your Telegram app and join again. Just as a side note, this event is recorded and will be published on the major podcast platforms really soon. So let's get started. I would like to ask to our guest first question. Like reinforcement learning has been and it is a very hot topic of discussion. And since the audience of our podcast is very various, there are people with different backgrounds, with different education levels, I would ask our guest to do us an introduction. Like, what is reinforcement learning? What it is? How can be used? Like, can you give us an overview to bring everyone up to speed on the subject?
Okay, good evening. Firstly, thank you very much for receiving us. I will start by an overview of reinforcement learning, the last successes of reinforcement learning. And firstly, reinforcement learning takes its root in the early 20th century with many mathematicians that thought of the concept of learning, what is learning, and some thought about the concept of trial and error. In our everyday life, when we try to learn, we try things and we fail or we success. Far later, in 2013, neural networks became the panacea with AlexNet, for example, that revolutionized the field of computer vision. And DeepMind thought that only by using vision you could succeed in winning at games like the Atari benchmark. The Atari benchmark is a set of multiple games that were run on Atari. And in 2013, they used neural network, computer vision, and reinforcement learning to achieve superhuman performances on this game. Only 3 years later, AlphaGo beat the world champion of Go, and it was a tremendous success because all the analysts thought that it wouldn't happen before 10 years, but AlphaGo was able to do it by reinforcement learning. And the next successes were AlphaZero and MuZero, and you didn't even need to provide the agent model of the game. Just by playing against itself, it was able to achieve superhuman performance on most of the board games like Go, chess, and other things. In 2019, AlphaStar becomes superhuman at a StarCraft 2. It's, in my opinion, at least as impressive, because in AlphaGo, all the actions were taken 1 per 2 minutes. In StarCraft 2, you have to take 3 actions per second to rivalize with world champions. So obviously, you have to process much more information in a shorter time, and only by having the images of the game. So it's really an impressive feat. And 2 years later, we go outside of the games. Google is able to create new processor core called the tensor processor units. It really speed up the training in deep learning. And by using reinforcement learning, they were able to create these new processors.
So yeah, that was an introduction of reinforcement learning, I guess. He has managed to gain a lot of successes.
Well, that's quite impressive. Like a very interesting overview. Like how these algorithms can achieve all of these goals and how much the research is investing on these. I don't know if someone from the audience has some questions or some comment uh, or something that they would like to ask to our guests. Well, seems like everything was pretty much clear on this point. So unless you have other points to share with regards to this introduction, I think we can move to the next pieces, to the next parts of our discussion.
Yeah, sure. We've shown you reinforcement learning like it's easy to succeed with. Of course, you can reach superhuman performance with reinforcement learning, but it doesn't it doesn't mean that everything is solved, or at least easy to obtain. When you think about what DeepMind has done and how DeepMind has succeeded to beat human champions, it needed teams of world-class engineers to achieve so. So what's very interesting about reinforcement learning is that it makes you able to try to do the same with the same algorithms. But training the algorithm itself is not an easy task. In fact, applying reinforcement learning in industries has been very difficult in the past few years for this reason, that reinforcement learning is hard to make work. Hard to make it work. It's hard to train it. It's hard to get a good hand at how it works and how you can make it work like you want to. It's hard to master. So it's very easy to try things out and to try, a new project or small projects, or to even make reinforcement learning agents on, on environments that has already been done. We've talked about Atari games. There is a lot of classic other reinforcement learning environments where it's very easy to obtain something that's working. But when you go out there in the outside world, well, it's a messy world outside. And to apply deep learning in the industries, we do lack of tools for now. There is plenty of tools that have been appearing around these reinforcement learning frameworks and so on, but nothing yet is, at least, has nothing has been used by everyone for now, because nothing is still perfect or outside what is expected in classic reinforcement learning frameworks. So we don't have like this super tool that we try to dream of for now that would enable us to apply reinforcement learning in every situation, and mostly in industries. That comes from a fact that reinforcement learning and supervised learning, which is very applied in industries now, are very different in their training processes. And maybe Raffael will talk about that later, because I think he's got something prepared on that. So I don't know if there is any questions on why it is difficult to apply reinforcement learning in industries, and why it is not that easy to obtain a superhuman reinforcement learning agent, although it is easy to obtain a reinforcement learning agent that is kind of working.
Well, that's a good point that you made, guys. Any questions on this, on why it can be complex to apply it on industry? Like, always as an introduction, like on what is reinforcement learning, how can be applied in academia and industry. Any questions? Any comments? Otherwise, we can move more. Otherwise, actually, I have a question for our speakers. Like, you mentioned that reinforcement learning is very hard to implement in an industrial setting. It's hard to use outside maybe academia, and you said because is lacking some main technology, some big frameworks, let's call it like that could be implemented in big within an industry. But what are, for example, the frameworks and the tools that you had occasion to use also, not only in industry, but also within academia and in your own personal experience? Like, and what are those used for? Would you like to share these with us? So, what are in rephrasing the question, what are the tools that you use? What are their names? How they're implemented? Like, how can they be used? Like, can you provide us some brief brief idea on that?
Yeah, sure. There is plenty of tools that you can try. It depends on what you want. As I mentioned, if you want to just apply an algorithm already done in a classic environment that is already done, and if you don't want to do anything new, just try out something that works, you have very nice frameworks like stable baselines or I don't know, a lot of them. RLlib, for example. There is plenty of them on the net. You can, well, if you type a reinforcement learning framework, you will find plenty of them. But you will also find that it's very hard to make them different from, make different things with that. Well, make special things or adapted things to your personal needs. And if you have a new agent or a new environment on which you want to try out, it might be difficult to do it. New environments can be a lot easier with time. When I first started to do reinforcement learning, we had to do, well, everything from scratch. Now we can we can use frameworks to make our life better, namely the one that I've said. In fact, I see that Raffael posted my old framework that I've made myself to log, because I wanted to, control the behavior of my reinforcement learning algorithm and to be able to log the metrics that were of interest for me at the time. And so I made my own little framework that Raffael posted on the channel, if you want to check it out. So those are answers. But there is no tool that will be like the main tool that everyone agrees on. It's the best tool. Because for now, it's not. We don't have yet a TensorFlow or a PyTorch for reinforcement learning, yet, at least.
And this is just as a curiosity. Do you think we're very far from gaining something like that, or we're somehow getting closer? Like, as your personal opinion?
I'm not sure. I don't know if it is even possible. To be honest, but if it is possible, I know that there is a lot of people that are looking for it.
Well, it could be a way to achieve reproducibility in the papers, because most of the time an agent can be trained any way we want. If it's a good agent, it will learn well. But if we don't know how it was initialized, in what trick they used that they didn't precise in the paper, we can't reproduce the results. So it's a necessary thing to have. But actually, currently, we don't have it.
Yeah, we don't have it, at least on PyTorch and TensorFlow. We do have it on JAX or other frameworks that are, well, coming out. And there is a few frameworks on reinforcement learning frameworks on JAX. RLAX and COAX, so to name two of those. Those are cool frameworks that allow you to have these nicely reproducible experiments, which is not the case of TensorFlow and Torch. But still, we don't have anything that everyone agrees on yet. And there is a reason for that. That it is because reinforcement learning is very general. Every learning procedure can be rephrased as reinforcement learning. In fact, all supervised learning is always a reinforcement learning experiment. When you think about it, you can rephrase it like that. And so it's very general reinforcement learning. And that's what makes it hard to make a good framework that allows you to do things easily, but also which is permissive enough to make you able to do anything. And for now, it doesn't exist. I don't know if it can exist, but if it does, it will be very nice.
We have the GYM framework that fit everything into an environment where reinforcement learning agent can learn, but we don't have something that makes agents in a standard process.
Yes.
Yes.
We have a way of doing environments for single agents in a good way, at least we have everyone agrees on GYM environments for single agent environments, and so it's easy to make your own GYM environment and to apply, as I mentioned, agents from, for example, stable baselines or frameworks like that. And so those are easy to apply. But once you start to have multiple agents or or maybe agents that are different, and you try to train your own agents, you run into problems.
I think we have a question from the audience, guys.
Okay, you can hear me? Sorry.
Yes.
Okay, I just had a question. You talked about how it was imagined like with the multi-agent system, and I was wondering what are the subjects, the domains where we had the most hope that reinforcement learning will be useful in the future. Where is it overseen to be here in the future right now?
It's hard to say because it could be everywhere, in fact. Everywhere where you have an agent that is learning and doing any kind of behavior, you could have reinforcement learning. But to be more precise, where it's likely that we will have soon enough reinforcement learning doing well, we need for that to have a simulator. A lot of the reinforcement learning academia for now is based on what we call online reinforcement learning, to the opposite of offline reinforcement learning. When you have online reinforcement learning, it means that you are able to try things out and to evaluate how those things are doing online, and to see, okay, I will try that, and what does that do? Okay, it makes me go into that state, and so I'm able to evaluate how good that action was. And it's not the case when you are working offline. When you are working offline, you work with a fixed dataset, just like in supervised learning, where you will work with a fixed dataset where your actions, you can't take a new action to see what it will do. So you are forced to learn from past behaviors and to then learn a good behavior based on that. And that is way harder to do. So, for example, everywhere where you have only a fixed dataset, a static dataset, reinforcement learning could apply in theory with offline reinforcement learning, but it will be way harder, and so it will be further in the future that it will come in those areas. But on the opposite, where you have simulators or models of what's happening, namely robotics is a good example of it, but not only robotics, also video games, of course, or anything where you have a simulator, you can have reinforcement learning quite easily. Even when you think about, data centers, or when you have, gesture, I don't know how to say that in English. When you have games where you manage a lot of things, and when you have a simulator of how to manage your things. This was not clear, sorry. I have a picture in mind, it's hard to say it. But yeah, my point is, when you have a simulator, reinforcement learning can come very fast in your subject. When you don't have a simulator, but you only have a data set, then it will be later. And if you don't have no simulator and no data set, it might come when we have general artificial intelligence, but it's clearly not for now. I hope I answered your question.
Theo, did it reply your question? You want to add something else?
It was very clear, thanks, and very, very large, and very clear. Thanks.
Well, thank you for the question, Theo. I think we might have other things to say if you want to. Namely, I did work in reinforcement learning, and if you want, I can talk about what I've done and why it was nice to do that.
Yes, that's definitely something that that we would be interested in. And tell us a little bit about your experience. And how was it to work in a certain type of environment, how you structured your projects, and what it's like to do an aerial project like in the real world, like in real life. So that would be very interesting.
Yeah. So I worked in an internship at RLAI, which is in the University of Alberta, where I've done research on reinforcement learning. Namely, my subject was how can humans learn from superhumans reinforcement learning agents, because we do have now at least the possibility to make superhuman agents on chess, Go, Atari games. We've said it before. Raffael said it before. So we have this opportunity of building superhuman reinforcement learning agents. But strangely enough, those agents are very bad at teaching what they know. The knowledge that they acquired is like stored into those matrices that they have stored at DeepMind. But even DeepMind researchers are not able to extract knowledge out of it. The only way that you have to extract knowledge of those agents is to, play against them, maybe, and learn from your mistakes, or maybe to try to analyze some games and some statistical facts about the move they made, for example. But it's very hard to do like it. It's just like if you had a teacher that would only say to you if what you've done was good or not, and that would only be able to say to you, this was the best answer, and that's it. You have no more explanations than that, and you trying to learn from a teacher that would only tell you, that was the best answer, and that was not what you've done. And that's it. Imagine learning from that. That's what we have for now. So my goal was to try to experiment and to think about how could we have something better. What are we doing as humans when we teach someone, when we teach something, when we have a behavior that we have in mind and that we want to teach? How do we do it? And that's what's cool about reinforcement learning, is that you can ask yourself some big questions like this and try to formalize it in a framework, in a mathematical framework, and to then make experiments on that. And that's what I've done. To answer your questions, in my research, what I've said is that to transfer a behavior, you can't just copy and paste your brain to someone. You can't just transfer your whole behavior. I can't transfer my behavior. If I know things about the world, and if I know how to fish or how to run, I can't just transfer my way of running and my way of fishing to Raphael's mind. I have to focus on some behavior bits that I will try to transfer. For example, if I want to teach reinforcement learning to you, I won't be able to teach how I live in general. I will just focus on some specific parts. And even if I want to teach reinforcement learning, when I will try to teach you reinforcement learning, I will have to cut my teaching experiments on small bits of knowledge that I want to transmit to you one after the other. And so the question arises, if you are able to cut your knowledge into those bits, that the things that we are able to do now in what we call hierarchical reinforcement learning, even if you are able to cut your knowledge into those bits, what bit to transfer first? What bit is the more important, or what is the bit of knowledge that you want to transfer with the highest priority? And so I say that for this you need to have this metric of priority. And I established three metrics to quantify this priority, namely the utility, so how rewarding this bit of knowledge is or can be. For example, if you want to fish and you don't know how to use a fishing pole, it's not that too bad, because you could use other things like maybe a stick. You can try to fish with a stick, but clearly it's better with a fishing pole. And so knowing how to use a fishing pole is useful if you it has a higher utility if you want to obtain a fish by yourself, for example. As you've seen, this means that it depends of the goal that you have. The second metric is frequency. Frequency being how likely you are able to use this bit of knowledge. And for example, fishing, if you had, for example, if you were in a world where fishing pole wouldn't exist, knowing how to fish with a fishing pole would be kind of useless, because, you don't have the opportunity to use it anyway. So even if it would be useful if you had it, because you don't have the fishing pole, you can't do that. for example. And the last bit, which is the bit that I focused on my research, was the learning complexity, which is how hard it is to learn this bit of knowledge. So how hard it is to learn how to fish with a fishing pole. So yeah, that was my research in a few sentences. And what I like and what's fascinating about reinforcement learning in those aspects is that because you work with a framework that is truly general in terms of learning behaviors, you are truly trying to learn how yourself are learning. How are you doing what you're doing in your everyday life? How are you able to even walk? And how are you able to succeed at going to fetch you some pasta boxes when you want to have a quick lunch? How are you doing that? How do you manage to learn to do those things? And those are questions that I think are fascinating to work on.
So somehow working on these technologies really change a little bit also your perception of learning, like in the sense of what it means to learn and teach, and the way we do things in general every day. Am I right?
Yes, you are. Definitively you are. And I think you can agree, Raffael.
I can agree, and even more. In neuroscience, reinforcement learning seems to be the way we actually learn. We have different areas in the brain that work differently, and this notion of hierarchical learning appears in the brain. I'm not a neuroscientist, so I can't go very deep into details, but we have part of the brain that learns by reinforcement learning, by trials and errors. We want to maximize a reward. That's why we can become addict, for example, because we have found a trick to optimize reward. And it happens in reinforcement learning in many videos, in especially one where you have a boat and you need to race, but at some point you have coins and rings that you can collect infinitely. And the boy just collect the coins and don't finish the race because it's the best way to optimize its reward.
Yeah.
And another part of the brain, you have the part where you have you want to do something. It's not the real action, but it's wanting to do something, and it's very different from doing the action itself. So when you are fishing, you are thinking about many things, but not necessarily about how you use your hand to catch the fish. You are looking at the end of the road, you are looking at if it's shaking or not, but you are not thinking about how you are moving to do it. And it appears in the brain, and we want to make it appear in the next generation of reinforcement learning agents too.
Because we are ourselves a good example of general intelligence, and we're trying to basically copy that. That's the idea. Yeah, I was making the point that maybe we went a bit fast on what is reinforcement learning and how it is different from supervised learning. Because for those maybe who don't know what reinforcement learning in details, it might be interesting to know what's the difference. I guess you guys are familiar with reinforcement learning, with supervised learning, but not with... Maybe you can mute your microphone, Simon, at least if you're not asking a question.
Yeah, I'm muted.
Thanks. So yeah, my point was maybe we can go a bit more into details why you guys are finding out questions, I guess, maybe on how to ask things. And yeah, you can go in details on what is, how is it different from supervised learning? Why is it different?
Well, I will go further into detail because we said that reinforcement learning was more general than supervised learning. We talked about online learning, which is a thing we must not do in supervised or unsupervised learning, or at least in most cases it's forbidden. So why can't we do it in reinforcement learning? To explain it easily, I like to take the example of when you want to tame a dog. you want to teach a little puppy to give the paw, and in order to do that, you will bow towards the dog and ask, please shake my hand. But the first time, the dog will be like, I don't understand human. Even more, it's a French person speaking English. I can't understand anything. So, you won't give the paw. Either you are a very, very bad person and you hurt it with a stick, for example. Either you just don't give anything. The next time you ask the dog to shake your hand, maybe some way it will be able to put its paw into your palm. And surprise, it receives a candy. A reward comes from the environment, and something happens in his head. It associates the fact of giving the paw with the reward. And as humans, we choose how we shaped our reward to make the good dog achieve the goal of giving the paw. So we have control on what we do in order to teach something, or at least for the dog to learn by itself how to achieve a goal. But that way, we taught by reinforcement learning to the dog to give the paw. And it happens in our everyday life. When you are studying for an exam, you want to maximize your grade with reducing as much possible the time you invest in studying, because it's a pain. And you have your loss function. It's a reward. It's maximizing something, minimizing something. And just by all the years you've spent in training for your exam, you're able to, you found the best way to behave, and now you're able to study 1 week before the exam because you find the optimal policy. We call policy the fact of acting in an environment. It's the term, but it just means how you behave in an environment to achieve a goal. And like I said, in fact, the end goal of reinforcement learning is reward maximization. We mentioned it with addiction, for example, or just a dog receiving candies. In reinforcement learning, we want to get the most reward possible, because it's not like supervised learning where we have a student-teacher relationship and we learn the relationship between data and labels. Here we want to induce a learning by the environment, and that's why we give a reward to an agent. And by that, it means that a human has the power to shape the way an agent will learn, and a bad reward can lead to terrible, horrible results. So it's very important to shape it correctly. And many great minds thought that this way of learning was the most close to general intelligence, because in a sufficient enough complex environment, just by shaping a reward, you're able to achieve very complex goals, and the term complex is complex by itself. But in an environment enough complex, if you have a goal and a good reward shaping, a good reward function all along the path of learning, you should be able to learn to do anything.
Yeah, I would go even further than that, because you said that rewards would come from the environment, but in fact, you can even say that rewards do not come from the environment. The reward that the environment is giving you is just an information, and your agent, yourself as an agent, you are able to attribute to those rewards or to what's happening into your environment, well, to a real reward. For example, if I play the Atari games and my goal is not to optimize my score, but maybe to to just die the quickest. Well, my objective will not be the same as what the environment is giving me. So as an agent, you can also choose your own rewards and what you will try to pursue and what you will try to maximize. And studying this is very fun because as a human, you start to study, why am I doing this? What am I trying to maximize there? Why am I behaving like this? And that's, things that you can quantify in the reinforcement learning framework. And so, yeah, that's fascinating science and a fascinating subject in general.
Thank you for sharing this. It was definitely a very interesting overview. And I managed to collect the question from Simone. So I will read it. It is addressed to Mathis, and he's saying about what you did in your internship. You talked of defining the difficulty of learning a task in order to give a reinforcement learning algorithm tasks that it can learn in a progressive way.
Yes.
Does it mean that with an advanced enough technology, we could train a reinforcement learning algorithm to correctly define the difficulty of a task so that algorithm alone could both define problems and learn how to solve them?
Well, define problems is a big word. It's hard to know exactly what you mean by that. But my goal, the goal of this technology would be, yes, to have an agent that for example, you release your agent on the chess game. The chess game is a world in itself. It has rules. Well, you can't do every action at each time step and so on. So it has rules. It has a hand when the chess game is ended. So there you go. It's just like a miniature world in a sense, right? And so you go and you launch your AI in this chess world. And she tries to learn. You're only saying to your agent, well, winning is great and losing is bad. That's it. That's what you say to him. And you give him a simulator, as I mentioned, of chess. So you give him the ability of playing chess over and over against himself. And so from that only, you are able to have superhuman performance at chess. You end up with a nice training, as I mentioned, and with experimented engineers, you manage to obtain with that an agent that beats all humans. So that's knowledge that has been produced by this agent on this environment. And the goal of the research that I've done is, okay, now I want to learn chess as a human. And I want to ask the best player in the world, which is not a human, how to play chess. And I want a better answer than just, this was the best move to do in this state. That's the idea. So the idea, yes, is to have agents able to discover how to behave in an environment, how to behave nicely in an environment, and then to teach how they've done it to humans. Just like when you are learning a new game and you are able to teach to your friends tips and tricks on how to win nicely or how to catch up. For example, if you play together, well, you are able to, say that, okay, you should learn this first because this is very useful, you will see. Or, oh, you should try this because it's often useful. It's not wonderful, but because it happens every time, if you don't know that, it will be bad for you. For example, you should learn this. This is very easy to learn, and it's quite helpful in games. Those kind of languages. Those are exactly the thing that we try to quantify and to measure on things that have been learned by an agent by itself. And so, yeah, the question is, with advanced technology, I hope that I could have my automated teacher, that I can just launch my AI at whatever task and whatever environment, and so it can summarize what is important for me to learn first, so I can learn way faster than what I would have done by myself. Or even with the help of humanity, for that matter.
Okay, guys, I would like to ask Simone if this satisfies his question. he can write to me directly. Otherwise, I would ask anyone else to ask a question to our guests of any type, and then we can move on. Okay, looks like there is no further question. Then I would ask you guys if there are other points or other curiosities I would like to cover before wrapping up the session.
Well, as you wish. I think we can wrap it up. We have other things to say, but it would take too much time, I guess. More than 5 minutes for sure. So maybe for another time. As this is the start of a collaboration, why not?
That sounds absolutely great to me. So I would like to thank you very much for joining this podcast session. I think this was really fun, and I'm really looking forward to publish this on all the different platforms. So thank you again. Thank you to everyone who joined the podcast, and I hope to see you soon in another episode.
Thank you for inviting us. It was a pleasure to be here.
Definitely, I hope we'll be able, as members of Automatants, to join again in your podcast and maybe sometime learn things with your podcast, which I hope will keep going like that.
Thank you, guys. See you soon.
See you soon.